Okay, welcome everybody. So we're going to talk about continuity of multivariable functions. So first of all, let's go back to what we learned in elementary calculus. That's the most important part. Remember that to know about the continuity of multivariable function is equivalent to know what was the conditions or the steps that you need to take to analyze continuity of a very basic function. So recall that. We say that a function like y equals to f of x is continuous at a value like a, x equals to a, if these three conditions are met. The first condition is a, that value, that the specific value, belongs to the domain of the function. A belongs to the domain. The symbol that we're going to use here is a, and I'm going to use a different color to specify that. We're using belongs to. This weird symbol belongs to the domain of function. So this is your very first condition. If a belongs to the domain, then you're allowed to go to the next step. If not, you're going to stop and say that, hey, a or that value is not in the domain of the function. 2, the limit of the function exists. The limit of function y equals to f of x exists at x equals to a. What's the meaning of that? It means that limit from left and limit from right exist and they are equal to each other. Or limit of function f as x approaches to a from right hand side is equal to limit of function f as x approaches to a from left hand side. Okay. So first we check if a is in the domain of the function, then we are allowed to go to the next step. What's the next step? We need to check to see if the limit of the function exists. Okay. Then the limit of the function must be equal to output value of the function. 3, limit of f of x as x approaches a must be equal to output value of the function at a f of a. So limit on the left is equal to output value. Very good. So I expect you to ask, this is a function in one free variable. So if we have a function in 2 free variables, what is the case? Exactly the same. Now, if you have z equals to f of x and y with domain D, we say that this function is continuous at x and y equals to a and b if we have 3 conditions met here. The very first condition, hey, that point, that specific point, a and b, x and y, must be in the domain of the function. So a and b, a comma b, belongs to the domain of the function. Well, what's the meaning of that? It means that the output value of the function is z is defined at that given point. If it's in the domain of the function, you're allowed to go to the next step. Hey, you need to check to see limit exists at that point. Well, we discussed different methods. We're going to review those methods as well. And limit of the function as x and y approaches a and b exists. And finally, the limit must be equal to output value of your function 3. The limit of f of x and y as x and y approaches a and b must be equal to the output of your function. So again, on the right hand side, you have the output. On the left hand side, you have the limit. So in that case, if these 3 conditions are met, you're going to say that, hey, my function is continuous at the point A and B.